And hello again. This is a video on partial fractions, and just as an introduction, let's have a look at something very familiar. So if you have this function 3 over x plus 2 plus 5 over x minus 1, if you add them together, you know that you'll get, you have on the bottom line you have x plus 2, x minus 1, and then on the top line you get 3 times x minus 1 plus 5 x plus 2, etc. I'll just keep going. 3x plus 5, so you get 8x, and you get negative 3 plus 10, so you have plus 7 over x plus 2, x minus 1. So you know how to do that, and this is something that you've been doing for a few years now. Now what partial fractions is in fact the exact opposite. What we do is we start with something that looks like this, and we go, well, this is a bit complicated for what we want to do, and so we actually go back to what we started with. We do the actual reverse process, so we're going in that direction. And the reason for that is probably twofold. Firstly, this is actually quite difficult to sketch, to do a graph of. It's hard to know what this might look like, and so what we do is we break it up into its pieces, and we know what this looks like, we know what that looks like, and so we add all the terms together. And it's not the terms, add all our coordinates together, and you can get a good idea of what that looks like. So that's the first reason we do it. The second reason we do it is for integration purposes. We don't know how to integrate this as a whole, so what we do is we break it up into two bite-sized chunks. We know how to integrate this, we know how to integrate this, and so it's much more serviceable. So that's why we do it, and so let's just have a look at what we do. So probably I'll just write down the different situations. Okay, so for every linear factor in the denominator, we write, so I'm a bit messy today, I always say that in every video, we write a over that linear factor. Okay, so we write it as that. That's the first rule. Secondly, for every repeating linear factor, we write it as, this won't make much sense at the moment, a over that linear factor plus some other number b over ax plus b squared. Okay, so if you've got some linear factor that's repeated, in other words it's squared, you've got the same linear factor happening over again. Okay, so so that's how we write it. This will make sense in a second. And if you've got and for every irreducible, explain that in a second, quadratic factor. So if you've got something like ax squared plus bx plus c, some quadratic factor that cannot be reduced down to linear factors, it can't be factorized, then we write that as, I'll use different, I'll use ax plus b, so a linear factor over that ax squared plus bx plus c. Okay, that's how we write that out. This won't make sense yet. Let's get into some examples. This will make more sense. Okay, so let's just jump straight in. Let's reduce 3x minus 2 over x plus 1 x minus 3. Okay, that's what we do. I want to break it up into chunks. So what we do is, what do we say? For every linear factor, we write it as, and I'm just going to write its equivalent to, we write that as sum a over our first linear factor, x plus 1, at the bottom line, plus sum b, we don't know what b is, over x minus 3. So that's how we write it out. And then all we do is put these two fractions together and figure out what a and b are equal to. Okay, so let's do that. So that equals x plus 1, x minus 3, and let's have a look. To get this new denominator of x plus 1, x minus 3, what have we times the bottom line here by? X minus 3. So we also need to times the top by x minus 3. So we get a times x minus 3. Okay. Now, for the b part of the fraction, what have we multiplied it by? We've multiplied the bottom line by x plus 1, so we need to multiply the top by x plus 1. So we get b x plus 1, like that. Then let's just expand the top. So we get ax minus 3a plus bx plus b on the top line. On the bottom line, x plus 1, x minus 3 still. And then what we're going to do is equate the coefficients. Okay, so this here is equal to this here. We just want to figure out what a and b is equal to. Okay, so let's just have a look at the x terms. X terms here, we've got 3 up here. So 3 is equal to, what are the x terms in here? We've got a here and plus b there. So we've got 3 is equal to a plus b. Let's have a look at the constant terms. And here we've got negative 2, and here we've got negative 3a, and there we've got plus b. And so again, we've got simultaneous equations that we need to solve for a and b. Okay, so just looking at this, let's just subtract those two equations, this minus this. So 3 minus negative 2 is 5, and a minus negative 3a is 4a. And so we get a is equal to 5 over 4, and b will be equal to, looking at this equation, b is equal to 3 minus a. So it'll be 3 minus 5 over 4. That's 12 over 4. 12 over 4 minus 5 over 4 is 7 over 4. Okay, so a is equal to that, and b is equal to that. I've run out of space once again, I'll try to jam it in. So therefore, our partial fraction is equal to, so this is equal to a over x plus 1. So, should I go to a new screen? No, because I forget all my numbers. 5 quarters, that's a over x plus 1, plus b is equal to 7 quarters over x minus 3. And just to write this a bit more neat, that 4 can just go down to the bottom line. So 5 over 4 x plus 1 plus 7 over, and that 4 can go to the bottom line, so 4 x minus 3. And this here is how we write it in partial fractions. So we have started with this, and what we've done is we've changed it into this. And this is the partial fraction. That's something that we can work with a bit more easily in integration and stuff. Let's just do more examples. Okay. 3 over x plus 1, x minus 2 squared. Okay. Right, so what's that going to be equivalent to? We've got a linear factor there, so let's write that. A linear factor will be a x plus 1. And then we've got this repeated factor here too, and so we'll have b over x minus 2 plus, and then we have to write it again because it's repeated, it will be x minus 2 squared. So that's how we do it. This applies to this linear factor, and this b and c here applies to this repeated factor here. So let's put all this together. Right, is equal to, let's write it. So on the bottom line, gets a bit messy sometimes, x plus 1, x minus 2 squared. Right, let's have a look at the a. What's the bottom line being multiplied? It's been multiplied by x minus 2 squared. So we have to times the top by x minus 2 squared. And that'll give us that. Here, for the b, what have we multiplied it by? What have we multiplied b by? Well, the bottom line has been multiplied by x plus 1, but it's also been multiplied by x minus 2. Great. And what about c? c needs to be multiplied, the bottom line needs to be multiplied by x plus 1, so I need to multiply the top line by x plus 1, so we get that. Not going to run out of space this time, I promise. Okay, I'm going to do some quick expansion here, I'm not going to sort of do it. So a times x minus 2 squared will be a x squared, and then we're going to get minus 4x there, so we'll get minus 4ax, and then we'll get plus 4, so we get plus 4a. Here, what will we get? We'll get x squared, so it will be bx squared, and we're going to get negative 2x plus x, and so that will be negative x, so negative b 2x, and then 1 times negative 2 is negative 2, so negative 2b, and here we're going to have plus cx plus c, okay, all over this. I'm going to run out of space. We all know it. Why should I even try to pretend I won't? Okay, and then let's equate coefficients, okay? X squared. Let's look at our x squared terms. We've got a plus b, and that's it. What are our x squared terms here? Nothing. So a plus b must be equal to 0. We haven't got any x squared terms. X terms, let's have a look at our x terms. We've got negative 4a there, and we've also got negative b there, and we've also got plus c equals 0. Because there's no x terms in this either, so that must be equal to that. And finally, our constant terms, let's equate our constants. We've got 4a there, and we've got negative 2, oops, that looks more like a 3, probably because I was thinking 3, minus 2b plus c, and that's equal to 3, because our constant on this side is equal to 3. And so again, just apply, I'm not going to actually do it, but just go through and do simultaneous equations on those. You can use your calculator, CAS if you want. That's how you do it. I'm not going to bother wasting time doing that. That's just a routine operation. Do that and solve for, and you'll get A, B and C, and then just write those numbers into this form here, and you'll have partially separated your fraction. Let me just check my time. I can't go over 15 minutes. It's on 11 minutes. Have I got enough time to do one more? Quickly do one more. Squeeze it in because that will make it into a nice place. Last example, something like, what would be a nice example? Let's do, quadratic factor on the bottom. And so something like 1 minus 2x over 2x squared plus 7x plus 6. So the first thing you'll look to do is to factorise the bottom line into two components. And can this be factorised? 2x and x. You go 6 and 1. 6 and 1 gives you 12. No. 6 and 1 there gives you 6 and 2. No. Try 2x, x. 3 and 2 gives you 3 and 4. Oh, it can be factorised. That's a pain in the bum. Let's just do that. Let's just factorise it. So that will become 1 minus 2x over, and then it factorises down to 2, is that right? So 4x plus, it's all pluses, 2x plus 3 and x plus 2. Once you've got that, and then you can write that as a over 2x plus 3 plus b over x plus 2, and then you can continue on your merry way and find what a is, find what b is, and plug it back into there. So I won't continue on that. I'll just quickly, that one didn't work because it factorised. Quickly, I'll just make up one because I know 3x minus 2 over x squared plus x plus 7, something like that I know doesn't factorise. So if you've got a quadratic there that does not factorise, and then what you can do is write that as, so every quadratic factor, what did I say before? I said that if you've got a quadratic factor, you can break it up into its pieces, and what it will be ax plus b over that quadratic factor. Oh, that's a ridiculous question. I'll stop the video there. I'll do this in the next video because I've pressured myself because I've run out of time. Next video, find it.